We'll be revising week 5 to 8. No?
Yeah, exactly.
Yeah.
So I'm just willing to discuss week 5 to week 8 only. So before that, in that particular week 5 week 8, if you have any particular topic to discuss, means inform me. I can proceed accordingly.
Okay, sir.
Any specific topic to discuss?
No, sir.
So are you okay with all the topics?
Yeah, yes, sir.
Okay, maybe I can raise some few questions. So based on that, you can give your opinion and the answers.
Yes, sir.
I hope you all can see my screen, right?
Yes, sir.
Yeah.
Yes, sir.
So I from week 5 onwards, I'm just asking some of the basic questions. So I have a small doubt in that case. So in the week 5, we have discussed something about the hierarchical architecture or hierarchical design, right? So what is the main role of that? Why we are using? Why don't you use a big module instead of hierarchical module? Any idea? You can put your answer on the comment or a chat.
So could you please repeat your question?
Okay, why we are going with a hierarchical design? Instead of that, we can bring up with a single module itself. Say, for example, I want to design CPU. For example, in that CPU, I can split up like for program counter. I am creating separate module. Arithmetic logic unit, arithmetic unit, I will separate unit, and register file separate unit. If so, what are the things are required? I have created separate submodules, like submodule 1 is program counter, submodule 2 is will behaves like arithmetic operations, submodule 3 may be register file handler or controller, or submodule 4 it be a controlling of all the devices. When I supposed to on, when supposed to off, like such a control unit will be there. Right? But I can have the same simple hierarchical one thing inter hierarchical. I can make a single module, right? Okay. So one of the answer given by Diksha Sone is for clear interface between the component. What do you mean by clear interface? Can I tell like clear interface like for example, um, if suppose I have a module which is set to be a program counter, this module is keep on adding by 4 byte like this every time whenever the clock pulse is provided to this particular unit as a input signal as one of the parameter called clock signal as a input parameter which is triggered at every past input signal symbol is clock, and it has been triggered at every passage like this common things or things all the things is there, and output signal is nothing but my program counter value. It might be either 16-bit value or 32-bit value. It depends on how much what type of instruction memory are using. Now in my particular module, in my total system, okay, this is one of the sub module. Now I got I have fixed, I'm just making up some other module, and in this particular module it is makes to do some kind of changes. What is the changes is you have to uh, it means that what kind of like for example, uh, the this particular device, each instructions are in 8-bit size. It means every instructions are available in a 1 byte location. First address is having first instruction, second address, next consecutive address is having second instruction, consecutive next instruction address having third instruction, and so on. But why I'm adding this kind of R plus 4? Any guess? Why we are having plus
Maybe the
4?
instruction is 32-bit, I guess.
Okay, so if I having 32-bit, okay, I have other question. If I telling that my processor is 30-bit microprocessor or 8-bit microprocessor or so on, what is the 32 refers to? Whether it refers to my data bus or address bus.
Database.
Then program counter, what is the role of program counter?
It's point to the next instruction
Instruction. Where the instruction would be holder?
inside memory.
Some of the instruction memory. I
Yeah.
called as IM. And you told you told like it is point to the address of next instruction. So it is just holding the address only,
Hmm.
right?
Yes.
But here you are telling that 32-bit microprocessor you are telling, and that refers to data bus, not address bus. But program coder is pointing only the address only. Then how do you think that the address is also 32-bit?
No, the address is 8-bit.
Address is 8-bit. Then if it is 8-bit, why let's say okay, in this action, okay, but I'm asking, basically I'm adding 4 means that I'm adding every 4 bytes. I'm adding 4 bytes. It
Hmm.
means 32-bit 32-bit, I'm just incrementing.
Mm-hmm.
But it does it address bus and data bus are same?
No, they're different. Address bus is the location of the instruction or the data.
Width of the address bus and data bus are same.
Sorry?
The width of,
No, no, no. The width of data bus and address bus are different.
if it's supposed to be different, any example, what kind of difference would be?
That in this case, you can say the address bus is 8-bit and
Which case you are talking about? This one?
this one, yeah. The
Okay.
address bus is
Let us hold. Forget about this part. I told the program initially I have designed on previous system which is 4 byte. I mean added by increment by 4 times. It means 32-bit in addition, and 32-bit addition is refers to instruction address point. I mean next address of the address width of the program coder is 30-bit. Okay, what is the size of this instruction memory? It has 32-bit address line, so 2 power 32 locations.
2 to the power 32, yeah.
Okay, and we are discussing about the 30-bit microprocessor. So the data bus length is also 30-bit. So any specialty in that case?
I didn't get the question. Can you repeat?
Is the data, since data bus here is 32-bit length, address is also 32-bit length. Is any added advantage there?
Maybe we can use the uh, same bus for data and address.
Exactly. So if I connected with one of the memory unit, and that is used for decoder purpose, okay, and this let me record as a memory, and based on the decoder I'm going to get some output. The decoder width is 32-bit, and memory is also holding 32-bit. Memory is also 2 power 32. So here it is address pointing. Based on the address, it gives a 30-bit output, which is the data. It might be a processing data or a instruction memory. Any code is supposed to be. and I'm going to process it. See here, the date of birth is also equal to address birth. Right? There is no, if it is different, I supposed to have the different decoder length. Am I right? Further, it may be a arithmetic logic unit or all the remaining processing unit. I don't care about it. I'm just talking about architecture wise. Think about other ways. If my data memory is 32-bit length, if it is data memory is 32-bit, and I have instruction memory is only 8-bit output, so totally I have 8 location, so it is a 3-bit output or 3-bit input. Okay, for this particular decoder, I need a separate decoder, and this is I need a special separate decoder because it's only having 3-bit line. But in this case, I don't want a separate decoder. Only thing is I want to distinguish myself that I'm taking the data, some value, which is from this particular part, it is I called as an instruction, or I can call it as a data. This you can study detailedly in architecture, computer architecture, where you can study something called multi-cycle operation. How do you handle all these things? And sound. What I want, why I'm including all these things is, so as usual, now back to the point. So here I inferred, like instead of that 30-bit at the data line, I'm going to use a 8-bit data line, or else my next every instructions are now going to available at here every instructions in a double word size. 32-bit with 4-byte location. First instruction requires 4-byte, second instruction requires 4-byte, third instruction requires 4-byte, like this. But memory is always focusing only on byte addressable, and here I'm expecting byte addressable location. So I just want to modify this number. Okay, if here it is a separate modular, then I just only do that, just changes only in this part only. I don't want to touch remaining systems, remaining part of system. I don't want to touch it. Only changes if happening in this particular. If I want to just change my architecture from 32-bit to 8-bit like this, I'm just designing differently. Only changes in this particular module, not to touch every other modules. Okay, that's what's a clear interface. So just small part I can able to touch it and can reuse all the same module again, and I don't want to introduce a new module and all. Okay. Do you have any question from Big for this particular topic? Hierarchical architecture designing. Okay, cool. Next one is I have some question from the register organization. Okay, let's say I have talking about register file. Okay, before that I have some architecture, and in that architecture I have some. Okay, let's define this first, then I will go with that particular part. This is my sorry, this is also a file. Is all my register address bus, and these are my data bus, and one control signal. Okay, could you tell me how many registers I have here?
2 to the power 15.
50.
15.
1 5.
Yeah.
Why?
You have drawn 3 separate address line, each of 5 bits.
Sorry, excuse me. Your voice is not audible. Can you please repeat again?
Am I audible?
Yeah. Okay, now you
Yeah,
can.
in the diagram, you have drawn three separate address line, each of 5 bits now.
Okay, so totally additive of all the things is gives 15 address line. That's
Yeah,
what.
yeah.
No, actually, all are addressing to this distance only. Okay, let's say I have four location. This is controlled by two line of address. So 00011011. Okay, let me draw like this. In this 2-bit line, I'm putting value 01. In this line, I'm putting as 10, sorry, 11 and 10 and so on. And this one, what is the address I'm feeding here? Respective data I will taken from here.
So then
Okay.
it's 8 bit, like 2 to the power 3 memory size.
Come in. 2 to the power.
3.
Why 3?
In the diagram, you have drawn 3 lines. I didn't understand the diagram itself, the register file diagram, not the
Okay.
this. Yeah,
So I'm just taking a small example instead of big example. This 5-bit line, I'm just taking a 2-bit line. So two address line refers to address line one, five address location, first register, second register, third register, fourth register. Totally, I have only 4 register in my register file. Is it fine?
I got it. Yeah.
Okay, and I have dedicated one line. This line, maybe I can label like this line as A line, this as B line, this as C line. All A line, B line or C line are 2-bit line, and if A line is particular line, I'll get the output for this line, and based on B value I get the B value here. Based on C value I can either read or write something. Okay, now is it okay?
Yes.
Now how many address line we have based on this?
3.
This is A line, B line, C line.
Yes.
In general, I have unique path, dedicated path, A path, B path, C path, like this. But all our path refers to the same locations only. Well, there is a chance for C is also equal to 01 also. Maybe I can give the address line for C is 01 also. I can give my, because it's a dedicated line, separate line, right?
Okay, got it. Then the address size will be 2 to the power 5 now.
Yeah, exactly. So totally 32-bit locations I have. In this case, I have 32 locations. What is the size of each location? How many bits I can able to store from here? Each location?
5 bits.
No. Think again. See here, I'm addressing one location. If I addressing this line, I get the value from here. If I in this address is meant for, okay, let's say I have B address, B value, which is 32-bit line. This refers to C. So what is the length of A output? What is output would be this one. This is nothing but data address. I'm taking something from the, if I give some address to the memory, what I'll get out? In the memory, I'm just giving address. From here, what I'll get it out? Okay, I'll give other way. Okay, this is the memory structure just as an example. So at the address of 00, means at the address at the mem of 0, I'm having 0 cross 10 some value. At the mem of 1, I having 0 cross 20. Similarly, at the mem of 3, I have 0 cross 40. Now it's okay.
Yes.
Now, if I am feeding this address, what I will get it out?
0 cross 1 0.
1 0. Similarly, if I feed some value, some address here, a address here, the a address respective output I'm getting, so, and what is this I called as a data of that particular address.
Mm-hmm.
So it means that I'm getting the data out of 32-bit output. So what is the value of each location? Each register is having, there are 32 locations have, each 32 locations is having length of
32 bit.
exactly. Got it?
Yeah, got it. Yeah.
Yeah. Now another question. Let me clear up all these things. Okay, so please excuse this label. The address, the label which I labeled as A of address line, I get the respective data of that address A. If I tell, if I give the address of B, I get the data of B. If I tell the address of C, respective C data. Okay. In this case, how many things I can read at the same time? How many things I can write at this same instant of time? At one instant of time, how many data I can read it out as how many 32-bit output I can read it out, and how many input I can write it.
Read means you means how which data are getting out of this register or getting inside the register.
Getting inside the register only.
At a time we can read only one and write two. Am I right?
If I give them address, I'm getting output. What is I call reading or writing?
Reading.
Okay, if I give address to the memory, this is given from CPU only. From the CPU, I'm giving some address to the memory.
Mm-hmm.
Okay.
Okay, I got it. At a time we can read two data and write one data in the
Yeah.
previous diagram.
So this is dual read.
Dual read.
Dual read put. At the same time, I can read two. Now it's okay.
Yes.
Yeah. So let's have simple example. Let us label this as register R1, register R2, register R3, register R4, register R5, R6, R7. Like let it be like this. Okay. And the register R0 is write protector like this. I have considered pins. It is always holding the value called 0. So I can't write anything in this particular register. As a design perspective, I have given like this. So we may give the address to this particular file register from address range from 001 to 111 because I have 8 registers. Am I right?
Yes.
Yes.
Okay. So ask again. I will repeat the same question. Reading address range, write address range. Okay. Could you please tell me how many address I can able to read from? What is the range of address I can read it? So if I feed some address through this, I can read the data. So likewise, if I want to read something from this register file, what is the range of address I can read it?
0 to 7.
From 000 to
111.
111. Writing.
001 to 111.
Okay. So as I previously defined, I have 2 read ports, let's say this is 32 bit, this is 32 bit. What is the length of this bit, this particular bus? These are my address line. So it is a writing process. For the writing, I have to pass the data in this address only, so in this bus only. So what is the length of data I supposed to write here?
32.
Only 32 only, because here it is mentioned 32 means every register inside the architecture is 32 bit only. I can give any different number. So this area I can read it from read data. Okay, so what is the length of address line or address bus?
3 bit.
Exactly, all are 333 bit. Super. Okay, so maybe I can label this is A label, B address, C address, DA refers to data A, data B, data C. So I just want to do some simple operation, assembly operation. Load R1 comma 2 comma R2, 2 of R2. Okay, so please excuse in this moment. This is a very good example, but at present it is not giving the good example because of some small minor differences. We have made it up as for the simplicity purpose only. But could you understand? Could you tell me what is happening in this particular type of operation? What kind of
Yeah.
operation is? Yeah. I'll tell you what is the because of simplicity, what kind of thing is not possible. I'll let you know all these things after and before the end of the session. What does this do? LD refers to basically this is a mnemonics, and this is refers to load something into the registered file called R1. Always in the RISC architecture, from right to left only. The process sources are the right. My sources are at the right, my destination are at the left. So here the left is R1. So this is nothing but R1 is equal to
2 times R2.
2 plus offset address, where offset is equal to 2 here. What do you mean by offset?
The next second next register.
So if I am telling some address like R1 is address, say 001 like this, and I am telling the R1 equal to mem of 001. If I tell means it will take the value from address 1. But here I am telling R1 equal to mem of R2 plus offset. It means what is the content of R2? Suppose if R2 content is 001, suppose. So what is the content of R1 will be?
Content of the memory location in R3.
Yeah. And the question may arise. See here, R2 is what size? R3 is what size?
32 bit.
And so the mem of address, here it is address I am telling at the length of 32 bit.
Yes.
Okay, that's the biggest. Because of our simplicity, we have taken only 3 bit of address line. It means that in a regular RISC-V architecture or any ARM based architecture, address line is about 32 bit length. So I have the register size of 2 power 32 locations. Is it fine?
Yes.
Okay, please excuse in this particular part because for simplicity only I adjust 2 3 bit address, but all other operations remain same case only, right? So any doubt in this register file handling and memory architecture, I mean instruction sets and all? Similarly, store word if I tell means, I think yes, W I think so. I'm not sure about what is the instruction. Something like this if I told means the content of R1 is supposed to be written at the location of address or at the content at R2 can address plus offset of 2 value. Put it your value of R1 in that particular location. That's the meaning of this particular thing. Otherwise, simply store R1 comma R2 if I said the content is supposed to be pushed to the location of something. That's the meaning of it. Okay.
Uh, Excuse me, sir.
Yeah, please.
Will the syntax will be given in the question or not of the instructions?
Oh, what is
I
you
mean,
asking?
will be the syntax of the assembly code will be given in the question or not? Like you told us, no, the two in the bracket means offset by two. Will that be given in the question paper or not? That I'm asking.
Um, yeah, we will insist clearly because it's not your risk computer architecture. So of
Yeah.
course we will inform you clearly. Otherwise, we will comment in the we will mention in the form of comments.
Hmm.
So from the comments, of course, if you know or don't know, maybe some people can consider SW, maybe something instead of store, they may think shift also. It's not a problem. But and the command I'll tell store the content of R1 to the R2 with offset.
Hmm. Okay. Thank you.
Okay, now the point I want to inform you. So I have some instruction called swap, something called R1 comma R2. From this, what do you understand? What kind of instruction would be looks like?
We're swapping the content of R2 and R1.
Yeah, so in the register file, I have R1, R2, this may R1, this R2. After execution of this particular programmed instruction, what happened? This content is supposed to be swapped accordingly. Okay, that's what the meaning of this instruction. And I have another thing called if I supposed then I'm telling that R2 load R3 comma R1 of 2 or something like this means take or let me R1 of 0 means take the value of R1 content and put it to the R3. So it means after execution of this instruction, the content of R3 will be copied to here also. Okay.
Yes.
Okay, now come to the picture. So let's start with the swapping operation first. So we are telling something called instruction memory, instruction register, register file, which are holding register from R1, R0 to R7. So it is a single, it's a dual port for reading and single port for writing. Okay. Now, if I execute this instruction, I supposed to take this R1 from here, R2 from here, and I want to pass it to my arithmetic logic unit or some other processing unit, and it has to give output to this way. Such that what happened? I want to store it. The resistor, the content of R1 and R2 supposed to be modified. Would you think it is possible in a single cycle?
No, we have to store one of the data, one of the register content.
Only one register can be stored, but I can able to modify both at the same time. If I want to modify, what I supposed to do? Your choice. You are free to add on anything. Maybe this is supposed to be exchanges kind of process based on my operations, based on my instruction. What I can supposed to do? Maybe can I add one more write register, write put. Do you understand? Acceptable? Is it this one way is acceptable? Special case, but it's not always. Just for
But you said you are writing both the data at the same time.
yeah,
But in the lecture, professor mentioned like there will be a problem if both the write operation addresses the same location.
yeah. So here I supposed to mention the address of R1. Here I supposed to mention of address of R2, R2 and R1.
Then it's okay.
Okay, if it is same location as usual, write protection will be happening. Maybe that's what I am telling. Two different location. The two location I need to be swapped. Okay, but this is too advanced level. I don't want to ask. But since I was
But
thinking whether,
at at the same time, we're reading and writing on the same like port.
yeah. So okay, let me go back to the same topic here. Okay, here I'm giving a okay. Let's say a equal to 001, b equal to 00010, c equal to 001, and DA is holding 0 cross 10. DB is refers to the address of 010, which is in this address I have the content called 20. I'm just doing some process, so that data I am getting something called 0 cross FF. So after completion of the first cycle, okay, what is the content of R1? Let us expand here. So imagine this is a total full circuit I'm just talking about. In that small part of this only, this one, okay, and remaining things like CPU or the ALU and other consecutive modules, control unit, okay, and data write, memory writes or something by pausing and put it back to here, and all these modules are there inside the CPU, and all are executing a single cycle. That's the biggest advantage of here. It means I take a very appropriate element design such that what happen, it can able to execute within a single cycle. The single cycle may be at 1 kilohertz, 1 gigahertz, or 2 gigahertz, or zero point 0.5 gigahertz. Depends on your propagation delay. We can consider the bigger. We can choose the bigger based on the critical path, longest critical path. We can choose that is the maximum frequency we can assert. Otherwise, we can't give the most, not beyond that particular frequency or something else like this. Okay, so the here I'm just telling some address. What I told, address I told to 0 cross 1, B address is 010, C address refers to 001. So it is refers to R1, this refers to R2, this refers to again R1, right? Is it fine?
Yes,
Uh,
sir.
so can you
Okay.
repeat? I once. Can you repeat once?
Yeah, so here I'm telling, I'm considering this example of selecting the address like this address. RA address is this is a 3-bit address line, which refers to which is pointing to register R1 and the register file. B address line, which is pointing to the address called register 2. C address line is pointing to the address of register 1 again. All are pointing to the same location only, respective location. This is refers to here, this is refers to here, and this also refers to the same location. Is it fine?
Yeah. Okay.
And
Yeah.
here I'm reading the data which give the address of the data of R1, which is the 10. and the data line B is pointing to R2 address, which use the address data value called 20. And because of some process, due to some process, or with this particular data, I'm passing these two data to my arithmetic logic and do some process and return back that data back to the register file. That data I telling that this FF. Okay, this is the right address, right data. These all are my read data.
You
Okay.
mean after processing the data we are writing to the register R1 is FF?
Exactly. That's what. So during this rising edge, the timing diagram is after some small propagation delay on that particular thing, I'll get the data of R1 address value maybe which is 0 cross 10 at R1. Okay, and after this rising edge, small perturbation time, it changed to 0 cross FF. How it is changed? Because I'm giving the control signal, which is nothing but write signal is enabled, read signal is already by default, there is no requirement for that. If write signal is enabled, then write operation of this line will be written. Because I have only one write port. It is happening parallelly or concurrently. Because I have dedicated ports. I don't have single port data line and single address line. I have separate address line, separate data line, and separate address line for one, separate read line one, separate read line two, separate write line.
Sir, I have one doubt.
Yeah.
Before the second clock pulse, isn't that the data FFB coming before the second clock pulse in the
Yeah, of
RAM
course,
individual?
that's supposed to be happen. That need to be happen. So I'll just expand it. So let's say like this.
Okay, okay. The
Okay.
data will come before the next clock pulse, but it will
And
get
exactly at
reflected
this
in the
writing edge.
register after the
Ah,
second pulse.
exactly.
Got it, sir.
Okay, and write is happening at the rising edge of this second rising edge, at the next rising edge only, not at the instantly. Even though ALU is giving the data of FF, it won't write immediately at that time itself. It will wait for next triggering pulse, because I need synchronous write. Why synchronous write? Why not asynchronous write, or why not instant combinational write? Does it give any problem of combination, right? Combination means combination circuit based writing.
Uh, then in combination circuit, we don't get the result instantaneously. The data changes like at the after a certain delay, we get the exact data.
It means so in the combination circuit, uh, after particular delay, what you
Yeah,
call
we
as
get the
propagation
result. Yeah.
delay, I'll get the data.
Mhm.
I can get some signal. Okay, so in my particular module, I'm reading instantly. But if I writing instantly, what may happen?
The data may change.
I don't know whether I writing the right data or wrong data.
Mhm.
So imagine in the same example, if in this R1 address I'm writing something as FF, in the same R1 data I'm reading something called 0 cross 10. AI assume that this data, the port of this particular data input is 10. Because of this 10 only, it do some computation and produce some output called FF. Imagine like that way. But
Uh, it will
if you give
it will take
output
the
of F,
it will take the FF data and it will also compute that data in that cycle also.
exactly. So I suppose this reading data need to be not very modified at that instant itself. It has to wait holding the till next rising edge. After that, maybe if I read the same data at the same data line address line, I can read the data of that particular line, modify data line. Okay. So reading is supposed to be a combination base, but writing is supposed to be sequential base. Okay. Is it okay?
Yes, sir.
Yeah. Any doubt in this regard?
No.
Okay. So I would like to add same circuit here. I hope we are since in the line. I don't want to ask too many different questions. Maybe I just testing you only. So again, let me define. This is right totally two read port, one write port, and reading is always happening in a combination logic. Writing is happening in sequential logic. I hope if you familiar with this topic. Okay, so tell me how many decoder circuits are required and what is the length, what is the size of decoder and how many multiplexer is required or mux are required and what is the size of each data line of my mux.
Sir, do we need two decoders
Okay, then
and
one mux.
one mux?
Exactly oppositely you're telling. So number of decoders are required only one. Number of multiplexer required are two because I'm reading two. I'm reading this one. I'm reading this one separately. So in the mux 1 and mux 2, what is my inputs of this mux means I have how many registers have here I have 8 registers.
8.
So all 8-bit registers outputs are taken as an input of this multiplexer input and based on the selection line it gives one of the output. This selection line is based on my address line A and this is my B address line. That gives DA and DB. Okay, does it looks okay?
Yeah, got it.
And what is the length of each line or width of each line or what is the width of each mux output line?
32.
Supposed to be 32 bit because in our example data line is 32 bit line. So each data line is 32, 32, 32 up to 32 times of 8 lines here. Here also 32 times of 8 lines. And here I have one 32 lines, another 32 lines, dedicated 32 lines. Okay. At the same time, in the right side, writing operation, I need only decoder, only one decoder is enough. That size is 32 bit length because I have 32 bit data line. Totally 3 lines of address which is selected to one of the register. Okay. In doubt in this regard? Maybe I can. Do you have any question from the instruction in encoding? Do you have any doubt in the ISA? Do you want to do some examples for handling ISA?
Yes, sir.
Okay. So since you are asking example, I'll just decide like this. My register file of 32-bit length of each register and total number of register I have is 4. Okay, how many address lines are required for each register handling?
2.
2. So 2 address lines. Okay, so I'm telling some instruction. In this instruction, the structure of the instruction is looks like as follows. First is opcode, then source address 1, source address 1. Let's say I'm telling this is my source address 2. How many destination line means? Okay, let me ask. One destination address, That's it. Maybe we don't want to add on these things. Okay, and I can able to compute this following operation, like I can do either addition, subtraction, multiplication, shift left, shift right, then and operation or operation. That's it. Only these set number of operation only. Very simple computing unit only I can able to perform it. There is no other option I can able to do so. Could you please tell me what is length of my output? Okay, I'll
3 bits, sir.
sorry.
3 bit.
Why?
We have 7 operations.
Exactly. So this is my ALU. Some symbol of ALU. It take two operands. Each operand is taking 30-bit length because my register file output is reading output as from the register file or 30-bit length. So I may get either respect to 30-bit output only, and that remaining bit may be extra bit may be considered as a status bit. I don't want to take into that too much detail here because you can study these things in the for computer architecture or something. Okay, what is there inside? How ALU will compute? And if I give data 1, data 2, how the ALU will compute addition or subtraction or multiplication division? Is there any decision making device is there here? Or it will do all the process, and how I get the respective output, not all the output. If every modules are there, like addition, subtraction, multiplication, all the thing means it may be computing all these things only. So how do I get output only the processed data, like required process, like if addition means it'll get the added result only, not subtracted result or shifted result or and operated result or operated result. It is not giving output. That's all the things. It just only desired operation only. It means what is the internal module will be, what does it consist of? It might be consist of any combination units you already have, such that the required thing can be able to select it so far.
It will compute all the operations, but only the selected operations will be getting in the output.
Yeah, based on the selected operation, I get the selected result from that particular operated result.
Yes.
So it means it has add sub all the, I have added result, I have subtracted result, multiplied result, all the things. But based on operation, I say if it is multiply means I get the output from this register and give it connected to here. Otherwise, I will get the respective part. How the system understand different, how to differentiate this? What circuit it might consist of?
We use a mux.
Exactly. So mux, if I tell, it needs some selection line. So here I have selection line called, how many selection I required?
3.
The number of
3 bits.
operations. So my opcode size of selection line I have. So as you said, I have 1, 2, 3, 4, 5, 6, and 7 operations are there. So I need 3 selection line. What is the length of source address?
2 bit.
2-bit. Destination address?
2 bit.
So source are 2 and destination address are 2-bit.
Yes.
I have strike with some. Okay. Well, so totally the length of my ISA is
9 bits.
Okay. Now from this ISA, could you please describe about this register file, like whether it is a single port or dual port or single
It's
write?
a dual
Yeah.
port read and single one write.
How you define describe it?
We have defined source address for 2 registers.
So since we have 2 source address, it means I supposed to
Dual.
read something. So
Yeah.
I need to read port. I have only one writing.
Mm-hmm.
Based on that, I can describe that my registered file is 2 dual read ports, and both are 2 ports are dual in nature because I have dedicatedly. I don't want to I mean, maybe we can read one after another also, but hardware circuit may be increased. And one write port. Okay. So based on all these option, okay, maybe I can define this opcode for this is 000 001, this is 010 011 on 100 101. This is 111. I have 110 is left unused. It's maybe reserved. Okay. Uh, Please tell me what is the ISA for this particular instruction. Add R1 comma R2 comma R3.
It will be 000 01 10 111
000
01
0
1
1.
10 11 10 11.
What is the destination? What is this instruction looks like? R1 equal to, or which is the equal app? What is here is supposed to be in normal computer paradigm? How can I write this code as in the form of assignment? Can you write in a C format, C code format with these variables?
R3 equals to R1 plus R2.
You are thinking, okay. Previously, I told you this is
Oh,
a
sorry. I got it. I got it. It will be 1 1. Yeah, it will be the opposite. R2
so
and R3 will be the source, and R1 is the destination.
so the source one is 10, source two is
1
11,
1
and the destination
0
is
1.
1.
Uh,
Okay,
yes, yes.
yeah. And if I write like this, I can able to distinguish everything. Like I mean, describe everything. Could you please tell me if suppose my instruction in the form of hexadecimal for this case, how do I represent it?
Wait.
Again, I'm just asking you to recall with your basic decision system only. Give me
2D.
1 second.
2D. Huh? 1 2. You told to write in hexadecimal.
Yeah.
Is it 2 8? Hello.
Yeah, 1 second. I'm just copy paste here, and now can read. How do I write in the hexadecimal? Let me group 1101. This 1101. Next 4 bit is 0010. Next is one single zero. Single zero can be what is the most significant bit supposed to be pattern here. So it is 000. If this particular bit is 1, then I supposed to pattern with 111. Okay. Since it is 0, no problem. So it is equal to 0
0 to
to
8.
E. So D. Okay. Okay, let me ask this simple question. Imagine the content of R1 is something like 0 cross or else 25. Okay. And I'm doing some operation like R1, R1, comma 1, which is nothing but immediate addition. with the immediate value. This is my immediate value. Then add R1 comma R1 comma R0. So what is the resultant value of R1? As usual, you know that source, destination, and which one is source and which one, or from the right to left only. You have to think accordingly. Please think and tell me.
Is it 26? We are adding 25 with 1 and then we putting it in R1. R1 is 26 and then we are adding R0 that is 0 with R1 26 and putting it in R1. So the result is 26.
Final answer also seems to 26. Here itself I got 26. Here 26 plus 0 is still 26 only. Okay. Now again I have other example. The previous operation, of course. I considered this instruction and I got some understanding like multiple because of this multiplier. It exhausts my energy, total power consumption because of this multiplier. So I remove this operation. So at last I understand that 110 operation or 010 operations are neglected. There's no such an operation. Okay. Now I just want to perform small operation. What this particular device, which is having all these operation units, if I pass some data to it, it has to give output just multiples, just 4 times of added value. If it is A, I supposed to get 4 times of A. Okay, let's start with 2 times of A. What I can do?
We can shift left by 1 bit.
Exactly. So I supposed to invoke left shift 1 time. Otherwise, 2 times do means multiply by 4. If I do 3 times or 4 times, that much times of multiplication may happen. But only option is only multiply by 2 times. I mean, two power of something only it is possible for this case. Well, I hope remaining things or I think there is no particular any question you have means you can ask me. I try to answer it. So
Sir, in the quiz, this type of question will be coming now. The thing you discussed.
I don't know. I didn't set this question paper.
Sorry, sir. Couldn't got.
Sorry, I didn't set this question paper, so I don't know what
Oh,
is it.
okay. Okay.
So, any other questions you want to discuss? Are you familiar with FSM models and hierarchical or design implementation using FSM model and all these things?
Sir, I didn't find any mock question paper in our portal. So
Yeah, of course, I don't have more question because the pattern seems to be more or less similar only as similar to the previous one. This time, um, I'll just prepare some mock question. Basically, all the questions it's just a mock question. No, I just give the pattern format so that you can understand what is the pattern of it. Probably, I'll just tell you the pattern like it is true or false. I think it is. Let me verify and clearly tell you. Give me one moment.
yeah, if you can share a mock paper in our portal, that will be very helpful.
Sure, sure. I'll just try to. Yeah, it's on just a minute. Just give me 1 minute. I'll just.
Mhm.
Just do yeah. So total marks is 40 marks, and in that 40 mark, true or false, 5 true or false, 1 mark question, and 15 1 mark question, MCQ type, and a 10 mark question. Okay.
Okay, sir.
And if you have any doubt regarding with that, you can ask me. And similarly, do you have any doubt from parallel multiplier, sequential multiplier, distinguish of parallel and sequential multiplier?
Sir, can you share any previous question paper in our G space?
Okay, I'll just check it again because I think maybe you can talk with your friends. No, they can share it. So
Okay.
the batch previous batch person may have these questions.
Okay, sir.
I'm not supposed to share, so that's what.
Mm-hmm.
Okay, anyhow, that's a good idea also. There is not because I don't use the same question again. It may be helpful for you to have solve several questions. Maybe I can get a concurrence from officials and then I can share it. I'm sorry. Okay, fine. If no questions, shall we wind up?
Sir, is this the last live session, revision session before exam?
I think it might be, but otherwise, my Saturday maybe my last live session. I didn't talk with Asutosh sir. If he is available, he can. Otherwise, this may be a last live session
Mm-hmm.
of revisions.
Sir, the syllabus will be from week 5 to 8
Week
or
five
from
to
one
week eight.
week 5 to 8. Okay, sir.
I think I have informed the same in the G space, and I'm
Yeah, yeah.
requesting if you have any questions or any disparities or any question challenges in the graded assignment and the practice assignment, kindly please post in the discuss forum. I hope everybody are aware about it or not. I don't know. Are you using discuss forum previously before?
Uh, no, sir. I haven't used.
You what you did in the digital system, basic digital system?
What I
Is it
did means
in the basic digital system? How do you connect discuss with the professor or course instructor?
in G space.
Oh, it's okay. That's the biggest problem. I think so. Okay, I'll just show you one screen to you. It might be at least from this moment onwards. Let's start practicing that also. I hope you can see my screen.
Yes, sir. It's visual.
So yeah, here you can see some message box at the right top corner. This takes you to the discussion forum. Next page. Yeah, I think yeah, it takes to that page. I forgot to log in because I didn't get any messages. That's what I didn't open it so for a long time. This is a very good area where you can discuss various problems of digital system or digital system design and so on. Okay,
Sir,
please
how can we
use
post
it.
our queries here? Like,
Huh?
how can we post our queries in this?
Yeah, here is something new
Okay.
topic is there, right? You
Mm-hmm.
can click and type your questions and please mention the tag like term 32325 term 2025 DSD. And you want to mention specifically to me also, you can put my handle like Prabhu. So automatically it pops to me. Please read the guidelines of it. Here I have mentioned the guidelines. Okay. What a
Okay, sir.
flow.
Thank you.
Okay.
Mm-hmm.
I hope you can use from this week 9 onwards. I think week 9 is no, that's just revision only. But anyhow, start doing. But it's very important to use this discussion forum. Okay, and even you can look at the previous terms also in the digital system design. Like what are the queries they are discussed in the previously? What are the queries they are discussed? All the things can be this. We can able to have actually you can read the command based on the commands you can understand much better than GSpace. Okay, thanks for patient hearing. If any
Thank you, sir.
question, Yeah, if no question, we can wind up. All the very best. Do it.
Thank
But
you.
if you have any doubt, even if you are unable to use discussion forum also, at this present moment, you can use GSpace. I can answer you in that particular space. But from week 9 onwards, let's do use discussion on discussion forum. Okay. Thank you.